You ever make a choice that just feels right, but you can't logically explain it? A gut feeling that seems to fly in the face of reason? Well, what if those irrational decisions aren't irrational at all? What if they're actually following a hidden and frankly powerful logic that comes from the world of quantum theory?
And that's the big question we're going to dig into here. We're going to explore this pretty revolutionary idea that suggests what we call irrationality might just be a huge misunderstanding of how our minds really work, especially when we're staring down uncertainty.
Okay, so here's our game plan. First, we'll dive into the rationality puzzle, why the classic theories just don't quite get us. Then, we'll borrow a pretty surprising toolkit from quantum physics to map our own subjective feelings. We'll put it all to the test with a simple umbrella decision, and then wrap up with why this whole new way of looking at our choices really truly matters.
So let's start with the basic problem. You see, for decades, the main theories in economics and psychology, they've all been built on this one core assumption about how you and I think.
The classical theory pictures us as these perfect rational calculators, right? Always weighing the odds, always making the most logical choice. But come on, we all know that's just not how life works. Our choices are messy. They depend on the context, on our feelings, and they often seem to just completely break those neat and tidy rules of probability.
And look, this isn't just a hunch. It's a real, documented thing called the disjunction effect. Picture this. You're offered a fantastic vacation deal. You'd totally take it if you passed your big exam, and you'd also take it if you failed, as a pick-me-up. But when you don't know the result of the exam yet, suddenly you hesitate. That hesitation, that weird break from simple logic, that is the disjunction effect. And it's basically the smoking gun that tells us the traditional models are missing something big.
So, if the old tools are broken, where do you find new ones? Well, researchers looked in a very, very unlikely place, quantum theory. And it turns out the math that was designed to describe the bizarre world of atoms gives us this powerful new lens for understanding our very old, very human habits. Okay, and this is super important, so let's be really clear. This is not saying our brains are tiny little quantum computers, no. It's about using the mathematics from quantum mechanics as a powerful framework to model the complex, uncertain way that we think. It's a tool, an analogy.
So why does this math work so well? Well, think about it. Classical models, they're rigid. They just fall apart when things get ambiguous. But quantum math, it was basically born to handle uncertainty. It was designed for situations where context changes everything. And that's what lets us finally build a model that treats our personal, subjective feelings not as errors, but as critical pieces of data.
Okay, so how does this actually work in practice? Let's look at how the model takes something as, well, fuzzy, as a gut feeling, and turns it into a legit geometric map. It's actually pretty elegant. It works in 3 steps. First, any situation, like, it looks cloudy outside, is treated like a quantum state, a qubit. It's not a simple on or off, but a blend of possibilities. Second, these states get visualized as points on a special geometric map. And third, and this is the really cool part, the exact location of that point is decided by how relevant you personally feel that situation is.
And that map we're talking about? It's called the block sphere. Now, don't get hung up on the physics. Just picture it as a kind of decision globe for your mind. It's a space where we can plot every possible mental state you might be in when you're facing a choice between 2 options.
So here's the absolute key. Your personal subjective feeling. That internal, how important is this to me right now? That feeling gets turned into a precise spot on this mat. It literally turns a feeling into coordinates. All right, I know this might still feel a little abstract, so let's bring it right down to earth with an example we can all get behind. The classic dilemma of whether or not you should grab an umbrella on your way out the door. And this is where the whole thing just clicks. Just like the quote says, you can think of this blockosphere, this decision map, as your own personal weather radar. It's not just showing you a black and white rain or no rain. It's mapping all the subtle shades of gray in between based on the data you are feeding it.
So let's play this out. You look out the window, you see these big, dark, angry-looking clouds. That feels super relevant, right? So on our map, that point gets plotted way out on the edge. It's got a huge gravitational pull towards, yep, take the umbrella. But now, what if the context is, the forecast says there's a 5% chance of rain sometime next week? That feels pretty irrelevant, so it gets mapped way in near the neutral center of the sphere with almost 0 pull on your decision.
But wait, it gets even cooler. See, the model knows we don't just look at one thing in isolation. We actually group different contexts together to form a stable cognitive structure.
And this structure is what explains why our behavior can vary. It doesn't tell you what you'll do with 100% certainty, but it predicts the probability of your choice. And that is the key to understanding why in the exact same situation you might grab the umbrella on Tuesday but leave it behind on Wednesday. Your internal cognitive structure, how you're weighing all the factors, has just shifted a little bit.
Okay, so let's tie this all together. What's the big deal here? What are the huge implications of seeing our decisions through this quantum lens? Why does this matter?
Well, if you take one thing away from all this, let it be this. For the very first time, we have a way to take something completely subjective, that gut feeling about how relevant something is, and turn it into a hard number. A precise parameter you can actually use in a scientific model. That's huge.
So to recap the big takeaways, our so-called irrationality, it might just be a different, more fluid kind of logic that the old models just couldn't see. All those personal feelings in the context of a situation, they're not just noise to be ignored. They are critical, measurable data points. And quantum cognition gives us the mathematical language to finally describe the mind's ambiguity, helping us build way more accurate models of how we really think.
And that kind of leaves us with one last big, mind-bending question to chew on. If our choices aren't just flawed or random, but are actually following these probabilistic, quantum-like rules, what does that really say about the nature of choice itself? And maybe even about the idea of free will? Something to think about.